Good evening, everyone. My name is Mansi Tripathi. I am TA for this course, Wastewater Treatment and Recycling. So, we are entering now in the 10th week of the course. So, this week is basically about the revision of what we have studied in the past weeks. In this week, we will see various examples of water and wastewater treatment plants in various cities of India as well as outside India, how they are working, how their behavior is, why if they are failing, why they fail, if they are successful, why they are successful. So when we will look into all these aspects of the water and wastewater treatment plant, we will be able to revise the course as well, and we will be able to gain knowledge. Okay, so for now, the quiz part, mean to say assignment sample question that I will be sharing, that is totally based on revision. So it will be good if you will solve together, and I'll be sharing my screen shortly. Try to solve the questions by yourself, and you can use the uh, activity tab to answer it. Okay, so I'll be sharing screen now, and you can solve the questions. I'll share the activities polls so that you can answer there. So allow me a moment to share my screen. So as you can see, we are in the 10th week, and this week is basically revision. You'll be able to solve the problems that you have solved earlier. So this is basically a compilation of all the older problems. Okay. So this will be the question number 1, and I'll launch polls for question number 1. I hope you can see question number 1 polls. Which of the following factors influence the selection of wastewater treatment unit? So now we know the what here in this question it is saying. We know the what pollutant we want to remove. We know everything about it. We know we have done all the quality and quantification of the pollutant. Now, what factors will be there that will help to decide the wastewater treatment units? One is desired degree of treatment, land and skill availability, available budgets, or all of the above. So as you have already answered, we'll see the answer. Answer is yes, you are right. Answer is D. All these things we will require to see to select the wastewater treatment unit. Desired degree of treatment, yes, we what is the end use? Like if we want to make water for any industrial use, it has to be a cleaned in a particular level. If we want to drink that water, the cleaning will be of some different level. That is one thing. Desired degree of treatment, land and skill availability. See, whatever our end use is, if there is no land available or the skilled or technical staff is not available, we won't be able to do that. So that is also a limiting condition that we require to see. Available budget, yes, financial requirement, financial constraints are everything for the water or wastewater treatment plant. If you have enough money, you can go for various level of treatment. If the money is low, we will choose such treatment technology that is low in budget but highly effective. So that's why answer is all of the above. Now I'll launch polls for question number 2. In the conventional ASP, means activated sludge process based wastewater system, secondary clarifier is placed right after grid chamber, aeration tank, primary clarifier, or flocculation unit. This is your question. You please try to answer this question. We are talking about conventional activated sludge process. So For any water or wastewater treatment plant, what is the general scheme that we follow? There will be first screening of the big waste, then it will go for some settling. uh, Sorry, it will go to some grid chamber. Is screening. Now it will go for some primary sedimentation tank. Now here ASP will come. In ASP, first treatment is aeration tank. Here we mix activated biomass with the upcoming water, upcoming wastewater, and then we allowed them to settle here in secondary sedimentation tank. And this whole process is called ASP, or activated sludge process. After that, here sludge is wasted and the flow comes out and we go for tertiary treatment. So what could be the answer from this? You can see. So the answer is aeration tank. You can see before SST aeration tank is there. Moving towards next question. The treatment process that primarily does not occur in simple constructed wetland is. See, this word does not occur. Okay. What is constructed wetland? In constructed wetland, we will use plants or any absorbent material that will suck the pollutant out of the water body. Either the water body, mostly the water body is static, or it can be moving with low flow. So we will use we will actually replicate the natural treatment system. Whatever occurs naturally, we will replicate them, and we will create wetlands, and this will absorb or remove the pollutant inside the water body. So phytoremediation means the uses of plant, adsorption if any substrate is there, complete disinfection and bioaccumulation. We'll see the answer. Answer is complete disinfection. Okay. Phytoremediation are there because plants will be there, adsorption due to substrate, and bioaccumulation will be there because plant will be absorbing something, and the thing that the any pollutant, for example antibiotic, will remain inside the plants, and if some animal that will eat the plant, this thing will go inside their body as well. So complete disinfection does not happen because every thing remains same. Disinfection, what do we try to do? We will try to remove the pathogens. For this we required some oxidation. So that is not possible in constructed wetland. Simple constructed wetland. There are more wetland technologies in which disinfection is also possible. We can put some solar panel, electrocatalytic chlorination that will help to produce chlorine, and we will disinfect it. Moving towards next question. In a constructed wetland, substrate is usually referred to. Okay, we have talked about there will be some substrate. So what is this substrate is actually? I have answered this question in the previous question. You please try to recall. Vegetation planted, under drainage system, sand and soil packed in wetland, gravel packs used as the entry and the outlet of the wetland. Wetland will be something like this. Sometimes there will be a liner system we can apply so that the dirty water does not penetrate. There will be some plants and here will be substrate. I hope you can answer this question now very nicely. Okay, we'll see the answer. Answer is C. Sand and rock placed in the wetland. Okay, this whole area is what we call substrate. Moving towards next question. Which of the following is not an advantage of wetland? Okay, not an advantage. Small area requirement, less expensive, simple construction, and simple operation and maintenance. This is a trick question. You can answer it. You can try to answer this question. I will give you a few seconds. Okay, we'll see. So the answer is A. See, this will be less expensive because no chemicals, no aeration equipment we are using. Construction is simple. What are we doing? We are digging a hole, we are putting things, and it's on. Simple operation and maintenance, there won't be any breakdown. If there is, it is simple to collect it. Plants, they require harvesting in some time, that we know. If there are plants, they will require harvesting. We can harvest them, make them as biochar, and can reuse them as substrate. All things are there. But the problem is area requirement will be high. Okay. So in constructed wetland, the area requirement will be very high in comparison to the other treatment technologies. This is question number 6. This is question about SBR, means sequential batch reactor. I will write it just so that you can remind it. Hmm. So, fill phase in a typical SBR mixed fill scenario indicates, what do you mean by fill phase? Both mixing and aeration not provided, either both of them are provided, or mixing is provided using mechanical mixer but the aeration remains off, or aeration is provided. So what do we do in the fill phase in sequential batch reactor? I hope you guys are well aware that there will be various phases inside the same batch: fill, react, decant, uh, here will be settle, decant, and idle. So these phases will be there. So what do we mean by fill phases, and what the things will be happening inside the fill phases? There will be aerator, mechanical or diffused. So what do we do when we fill it? Do we mix it, or do we aerate it, or we do not do any of the above? Okay. So we'll see the answer. Answer is C. In fill phase, mixing is provided, mechanical mixture, but the aerator remains off. When we switch on aerator, we switch on aerator at react phase. Okay, at this phase, we will switch on the aerator so that oxygen full condition can be prevailed inside our water body, inside sequential batch reactor, and all the reaction can happen in the aerobic environment. Okay. This is question number 7. This is a matching type of question. This we have to match the regarding SBR. What will happen when? What happens in decant? What happens in react? What happens in settle? This you should answer. Organic matter degradation, suspended matter removal, or treated water removal. What happens in what phase? I've just explained various phases of SBR. You can answer in the chat box. Okay, we'll see the answer now. So the answer is B. Organic, see, starting from fill phase, nothing will happen. Then comes react phase. In react phase, what will happen? All the organic matter which are soluble, they will react. What happens in settle? All the organic matter that have been reacted and they will settle down. And what happens in decant? What do you mean by decant? All the solid samples will have been settled down, so there will be water above that. So we will just twist our this thing. This is your sludge. This is sludge. Water is there. Water will come out. So this is what we call decant. What happens in decant? Treated water is removed. Moving towards next question. In which of the following treatment methods the biomass grows as a biofilm on the carriers that move freely into the wastewater? That is the question. Here it is saying that the biomass is not in suspension, means suspension and attached difference. In suspension, it is filled with water. We will have biomass as different places. Okay, this is what we call suspension. Now, what is attached growth? In which there will be some media, some plastic media or any kind of media, and biomass will grow on them. So this is what we call attached. So it can be like this, or it can be in the form of filter. This thing is filled with media and the biomass growing around them. Packed. This one is packed. So both of these systems are attached. But here the question is, here it is saying that the carriers are moving freely, means we are talking about this case. Here the carriers are packed. They are not at all moving in this case. No movement. But here the carriers are moving. So we are talking about this case. So what could be the answer? Let's see. So the answer is D. SBBR and MBBR. Sequencing batch biofilm reactor. This thing happened because we will add some plastic. I'll clear the screen for you. We will add some plastic media or any other media. Plastic media is what we usually use. And MBBR, moving bed biofilm reactor, we will use. In this, around the plastic media, the biofilm growth is there. So it can be of this type. It is filled with media. So water will come here by force and the media will be fluidized. It will move up and down. Okay. This is how it will be. Moving towards next question. Question number 9. Which unit of the classic ASP is replaced by membranes in MBR? Earlier, what is ASP? There will be some aeration, either mechanical or diffused. So this will be filled with water, and if let's talk about diffused aeration, so bubbles will come, or it may be like this also, anything is fine. And this is what we call ASP, activated sludge process, aeration tank. So the question is, which unit of the classic ASP is replaced by membranes in MBR? when this aeration tank is combined with uh, secondary sedimentation tank, this whole process is called ASP. So there are two things in ASP: aeration tank as well as secondary sedimentation tank. So which unit has been replaced by membrane to make it to convert ASP into MBR. Primary sedimentation tank, see, it's not at all there. Secondary sedimentation tank is there, aeration tank is there. So we'll see. So the answer is B, secondary sedimentation tank. So what happens in this aeration tank itself or just outside the aeration tank? We will put our membranes. So this in secondary sedimentation tank, what was happening? The particles were separating, right? Liquid will flow above and the sludge will settle down. So what is happening in membrane? All the flow is passing through this membrane. So what is happening? All the sludge is remaining here only and the clean water is going. So there is no need for secondary sedimentation tank. Also, the quality of the water was better than the conventional ASP. So which treatment unit is removed? Secondary sedimentation tank. Next question is, which of the following treatment technologies is the most effective in suspended solid biomass removal? Suspended solids and biomass removal. We are trying to remove suspended solids as well as biomass. MBR, SBR, MBBR, SBBR. It's important that you should know all these full forms. These are very common terms. So basically we'll be using these terms only. So it's imperative that you learn the full forms. Okay, we are trying to remove suspended solids as well as biomass. We don't want both of them in our treated effluent. Okay, as you have answered, so we'll see the answer. Answer is yes, you were right. A. MBR, in MBR, what is happening? Membranes will be there that will remove suspended solids, as well as if the pore size of the membrane is very small, means ultrafiltration is there, then biomass removal can also happen. Okay. Fine. In
I
other
have a small
technologies,
question. Uh,
membranes are not being used. We are not
I have,
using membranes.
no, I've just got a small
We
question.
are just using ultrafiltration. In only in MBR, we are using membranes.
Okay.
Moving towards next question. Which of the following is a distinct advantage of submerged MBR compared with external configuration of MBR? Okay, so what as I told you, this is your aeration tank. We can install MBR here, or this is aeration tank. We can install MBR outside. Both of the things we can do. This is called inline or internal configuration. This is what we call external configuration. This is aeration tank. This is MBR. Aeration tank, MBR. So advantage of submerged MBR. Submerged MBR means this. So the question is asking about the advantages of submerged MBR over external configuration. Can operate at higher fluxes, lower energy consumption, better control of membrane fouling, easier membrane replacement. What can happen? Okay, as you have answered, we'll see. So the answer is B, lower energy consumption. Okay, I'll clear the screen so that you can easily see. Submerged SBR, there will be lower energy consumption and less rigorous cleaning. Okay, and but in the external system, membrane fouling will be like whereas more direct hydrodynamic control of membrane fouling along with easier membrane replacement, a high flex advantage offered by external configuration or MBR. See, membrane fouling will be the bigger problem in internal structure. This membrane will always be submerged inside the water, so fouling will be more fouling. But the energy consumption will be less and space consumption will also be less. You can see it's not outside, it's inside. Our next question is, compared to conventional activated sludge process, MVRs are operated at. So here we are talking about advantages of MVR over ASP. Lower oxygen requirement, higher reactor volume, higher sludge concentration, or low energy requirement. I'll wait for the answer you can give, then we'll see the solution. Okay, let's see. So the answer is C. C. Low oxygen requirement, that will be there because now we are not mixing it completely. Higher reactor volume, higher reactor volume, no, like we are removing one more unit. Okay, we are removing a SST, secondary sedimentation tank, so the overall volume of the plant will reduce. Also the reactor volume will reduce because now the microorganisms concentration in case of MBR will be 4 to 5 times more than the ASP. So the reactor volume will be divided by 4 or 5. Higher sludge concentration will be there in MBR, yes. Lower energy requirement will be there, no, because now for the cleaning of MBR, all those things or more sophisticated equipments are required for the cleaning. Now moving towards question number 13, the degree of fouling in an MBR depends upon. Fouling means formation of any precipitate or biomass on the surface of the membrane. I hope you remember I have explained you different types of fouling mechanism, pore plugging, uh, pore narrowing, as well as gel or gelatin layer formation. Feed and biomass properties, membrane properties, operating condition, or all of the above. So the answer is all of the above. All of these things are important to control or to determine the degree of fouling. Okay, this was a simple question. Moving towards next question. The MBBR is typically seen as upgradation over ASP, SBR, MBR, or constructed wetland. So we will add plastic media in one of these units, and that now that media we will call MBBR. So in what unit we add just plastic media or any type of media? Okay. So the answer is C. In the addition of plastic media we can do in any of these things, but we are talking about the upgradation. SBR is better than ASP. Cost wise it's equal to or sometimes better than constructed wetlands, and this MBR is way more better than SBR, because reactor volume will be low and we don't read now secondary sedimentation tank. So this MBBR, this will be the combination of MBR and ASP. Okay, so that is why answer and ASP is there. In ASP only we are adding media, but the performance will be better than MBR itself. So that is why we will say that it is an upgradation over MBR. Okay, answer will be no. I'm sorry. Answer will be ASP. Answer will be ASP. This MBR won't be there. I'll explain it properly. See, in ASP only we will add some plastic media, and what changes we will do? We are adding plastic media, that is first change. And in ASP usually what was happening, water was coming from here, but now we want we don't want this. Now water will come from here, feed, so that feed the organic matter in the feed, and this plastic media is in contact. This media will be so light, then when feed water is coming, it will jump inside the water. So that is what we want. So that is why it is an upgradation over ASP. Okay. So the last question is, the material used to make biomass carriers for MBBR should have density. See, now what is our objective? We want this media to always be in motion. So we cannot make it heavy, right? In MBBR, we cannot make it heavy. It has to be very light. So the lightness of this media is compared to water. So how much, what kind of density we want? Less than water, equal to water, more than water, or density of the material is not a criteria. So this is the anyway wrong, because the media will be in floating condition only when its density is lower or equal to water. Water is coming only na feed. So what we can maintain? So the answer is B, close to density of water. So we will use very light media whose density is closer to water, so that a frequent contact between the organic matter present in water and the media particles may happen, and the bacteria may easily degrade the organic matter. So that's all for today. I'll clean this so that you can see easily. Any doubt? Okay. Thank you. So I'll close lecture. Okay. Thanks for joining. Bye bye.
Thank you. And sorry for being late.